of the day to all. I am Shikha Kansal and we will be talking about type 1 and type 2 errors when we are talking about hypothesis testing. So, what is type 1, type 2 error, along with what are the different significance level and along with what are the different kinds of test, one tail test, two tail test we will be revising side by side. So, how to find out the critical or the rejection area when we are talking about a simple problem. The area under the sampling distribution curve of the test statistics is divided into two mutual exclusive regions. Exclusive means which cannot occur together. So, these regions are, one is acceptance area, which I am going to accept as a researcher, and one is called as a critical area or the rejection area, which I am going to reject. Generally, on a normal basis, we reject the null hypothesis, that is H naught, and we accept the alternate hypothesis, which is either H A or which is either equal to H 1. Few places you will find out alternate hypothesis as H A, and at few places you will find out H 1. They both mean the same, but yes, it means alternate hypothesis. When you accept the region, the acceptance area represent this range of values of the sample statistics and spread around the null hypothesis population parameter. As I have told you, acceptance area is basically, it talks about what we are accepting out of what we have, what we want to find out, whereas when we talk about rejection area is something what we are not taking into consideration the next time when we are talking about that same problem. If the values of the sample statistics falls within the range, that is in the limit of acceptance area, then the null hypothesis is accepted, otherwise it is rejected. In major of the cases, we reject the null hypothesis. I am again repeating, in major of the cases, we are supposed to hypothesize a problem in such a manner that we reject the null hypothesis. That means, your H naught is rejected and your alternate hypothesis is accepted. Now, the rejection region represents the value of the sample statistics that falls outside the limit of acceptance area. Obviously, if I want to gather a data of people who are up to the age limit of 50 years and somehow I gathered few data which is of the age of people between 60 to 65, then I am going to reject that data. I will only accept the data of the population which is related to my problem, that is up to the age of 50 years. So, the rejection area, the rejection region represents the values of the sample statistics that falls outside the limit of acceptance area. Consequently, null hypothesis is rejected. The size of the rejection area is related to the level of precision to make the decision about the population parameter. This rejection region is related to the level of precision. This level of precision either has to be 1% or it has to be 5% level of significance. The value of sample statistics that separates the region of acceptance and rejection is called as a critical value. That is, either it is written as TC or it is written as just CV. Therefore, what we can talk about critical value is, a critical value is nothing but the level of significance represented by alpha is used as a cutoff point between, or a cutoff point that separates the area of acceptance and area of rejection. For example, if we have a bell shaped curve here, then this part, if we are talking about a one tail test, if this is the part, this is acceptance area and this is rejection area, then this line which separates the acceptance area and rejection area is represented by alpha, which is called as critical value. Now, what is the decision rule as to when you accept the null hypothesis or you reject the null hypothesis is, if probability says that your null hypothesis, that means H naught is true and your level of significance is less than whatever level of significance you are taking, whether it is 1% or it is 5%, then we reject the null hypothesis. But if the probability, that is H naught, is true when your null hypothesis is greater than your significant level, then you accept the null hypothesis. These are two things which you are supposed to keep into mind when we are talking about significant level, or when we are talking about a critical value. This critical value, this level of significance either has to be 5% or it has to be 1%. What is the meaning of 5%? What is the meaning of 1%? It means, if for example, we are taking 5%, that means out of the lot, out of the population, out of the mass of 100, if we are taking it as 100, because the highest percentage is 100. So, out of 100 people, out of 100 chances, out of 100 occurrence, out of 100 units which we are taking as sample, there are 5 chances on which we are making a mistake, or there are only 5 chances which lead to a wrong decision out of 100 chances, but 95% chances are right. That means 95 times we have taken a right decision as compared to 5 of those chances. In the same manner, when we talk about 1% level of chance, that means there is only 1% level, there is only 1% level of significance, that out of 100 chances we make 1% chance, we make 1% decision which are wrong. That means, if we have 100 population, that we are taking right decision 99% and we are taking only 1% chance, that means we are taking only one time the wrong decision. But the rule for level of significance remains same. That means, H naught is true if in probability, if in question H naught is true when your level of significance is less than equal to, then we reject the null hypothesis, and just the opposite, we accept the hypothesis when your H naught, that means the question which you are asking in H naught is greater than your significance level. For example, if you have a bell shaped curve here, this bell shaped curve, if we are talking about 5% level of significance, that means this whole area is 95% and this part is 2.5% and this part is 2.5%. Although we never talk about percentages when we are talking about a bell shaped curve, we are supposed to talk about numbers. That means, you convert this into number is equal to 0.025. So, here we will take this area as 0.025, which is null hypothesis. This line is called as critical value. This area is rejection area and this whole area is acceptance area, because the value of statistics lies in this area. In the same manner, since there are two tail test, this is again my null hypothesis and this shows my alternate hypothesis, or you can write down H A. This again is H naught, which is rejection area, and this also corresponds to 0.05. If this area is alpha, level of significance is alpha, then if this whole area is 1, if we take it as 100 population, if we take it as 100%, then this is represented as 1, the highest is 1, minus alpha is this part. Now, 1 minus alpha is this part, that means this area, the side, two sides area will represent the alpha divided by 2. Why? What alpha is remaining here is alpha by 2, because we have divided this alpha into 2 equal parts onto the both sides of the bell shaped curve. This again is alpha by 2. So, what happens here is this area which is the acceptance area and this area which is the rejecting area, this is shown, we are accepting the null we are accepting the alternate hypothesis here, the center part, and we are rejecting the null hypothesis onto the two sides of the bell shaped curve. This area is rejecting and this area is accepting. This is all what we are supposed to do in two-tailed test. The same manner we can go for one directional, that is one tail test, right hand side test or left hand side test. Now, how to select a suitable test for significance or test statistic. The test of statistics or test statistics can be classified into parametric test or non-parametric test. The data for parametric test are derived from interval and ratio measurements, whereas the data for non-parametric test are derived from nominal and ordinal measures, which we have already studied in the other subject. Now, there are certain assumptions when we talk about parametric test of significance values. Each element or the member of population should have an equal chance to come out. That means, if we are taking 1000 number of people, if we are taking 1000 people under the as a sample, that means all 1000 should have an equal chance to come out as a sample. So, from the population, each and every item should have equal chance to being selected as a sample. So, from the population, and in non-parametric test, if significant, do not specifies normal distribution population, it could be some other population as well. We cannot take it as only normal distribution population, it could be some other population distribution as well. So, how to select the selection of the test of significance, how it has to be done? It totally depends upon number of samples, whether it is 2, whether it is 1 or whether it is n numbers, or we can talk about whether it is k samples. Samples are independent or not. So, the selection, the factors which are considered while choosing a particular test of significance, which test of significance you want, whether you want 1 level of significance, whether you want 5% level of significance, that totally depends upon the number of samples, the samples are independent or not, and the measurement scale which you are choosing, nominal, ordinal, interval or ratio scale. There are different kinds of scale which we have already studied in research methodology. These are the different kinds of scale onto which the test of significance depends. Beside these, the investigator should also know what is the sample size, the number of samples, and the data have been weighted or not weighted. Now, how to formulate a decision rule to accept a null hypothesis? Compare the calculated value of the test statistics with the critical value and also called standard table value of the test statistics. That means, you are supposed to calculate your mean, your actual mean, along with the hypothesized mean which you want to find out. If they are equal, if they are not equal, that is supposed to be done when I want to find out whether to accept the null hypothesis or whether I want to reject the null hypothesis. When my statistics value falls within the area of acceptance, then I accept the null hypothesis, but the chances of accepting the null hypothesis is very less. That is why we always take the opposite of what has to be accepted as the null hypothesis, and what I want to be rejected is always taken as null hypothesis. So, we compare the calculated value of the test statistics with the critical value, that is alpha, also called as standard table values of the test statistics. The decision rules for the hypothesis are as follows. If the test statistics value falls within the area of acceptance, then we accept the null hypothesis. That means, if this is my bell shaped curve and my value lies on a small portion which I want to be rejected, which I already had made as a null hypothesis, if my statistic value falls in this region, that means this is H naught, I am accepting it. I am accepting my null hypothesis. Otherwise, if my value lies in this part of the bell shaped curve, then I will reject my null hypothesis, and my aim is to reject the null hypothesis. When I accept the null hypothesis, it leads to an error. There are different kinds of error, type 1 error, type 2 error, which we will going to study further, but yes, my motive is, the researcher's motive is generally to reject the null hypothesis. In other words, if the calculated absolute value of the test statistics is less than or equal to its critical value. In other words, if the calculated absolute value of the test statistics is less than or equal to your critical value, then we accept the null hypothesis, or otherwise we reject the null hypothesis. This is what I have explained you according to the graph. If my value of statistic, if my value absolute value of the test statistics lies within the shaded area here, that is null hypothesis which I thought of, is lying in this area, that means I am accepting my null hypothesis. Otherwise, I am rejecting my null hypothesis. When I am rejecting my null hypothesis, that means the value of statistics lies in this area of my bell shaped curve. This is the major portion which is called as a alternate hypothesis, and my statistics value, absolute value of test lies in this area. That is why I am accepting my alternate hypothesis and I am rejecting this null hypothesis. Just now we were talking about two different kinds of errors which we generally make. If we are accepting the null hypothesis, what does this mean? What kind of error we are making? And if we are rejecting the null hypothesis, what does this mean? What kind of error we are making? Since decision to reject or accept a null hypothesis is based on a sample data, there is a possibility of incorrect decision or error. Since we human beings, we are the human beings and we tend to make mistakes, so it totally depends upon what kind of responses we are giving, what kind of decisions we are taking, and what kind of sample data we are taking from the population, whether that sample data is right, whether the sample data is motivated to give you the right answers, or the sample data is 100% accurate. That totally depends upon your incorrect decision or your correct decision. So, a correct decision maker may commit two types of testing errors, which when we are talking about null hypothesis. So, when we accept the null hypothesis, and when we accept our null hypothesis and your hypothesis, null hypothesis is true, that means correct decision with the confidence, that means the decision which is lying in the small part is right, that means we are making a type 2 error which is designated as, which is written as beta. Whereas, if we reject the null hypothesis and null hypothesis is false, that means we are making type 1 error which is represented as alpha. My whole population is 1. I am supposed to take right decision. Right decision means I am supposed to not to make errors. That means I am supposed to take, the population is 1, my probability of making the error is very less. When it is very less, when we are talking about less, that means it has to be 1 minus type 1 error, that is alpha, that means my decision is correct. Whereas, if I reject my null hypothesis, that is if my H naught is false, if my H naught is false and I am rejecting my null hypothesis. Obviously, when my H naught is wrong, I am supposed to reject it. So, this is my type 1 error, that means I am taking right decision. For example, if I say if work commitment leads to organizational success, then if work commitment leads to organizational success is my question, then if I take that work commitment is not leading to organizational success, that means it is my null hypothesis, because I am taking it as that it will be obviously going to reject. So, when I know that it is going to reject and at the end of my statistics also it is being rejected, that means my H naught is false. That means the statement which I made that work commitment leads to organizational success is also wrong. That means I am making my type 1 error. I have made my decision correct, or I have taken correct decision. So, what is the probability that I have taken right decision totally depends upon rejecting or accepting the null hypothesis. If we explain the same question for beta for type 2 error, if for example, I am taking the work commitment leads to organizational success, if I think I am taking H naught, that is null hypothesis, as work commitment is equal to organizational success, that means I am making a wrong null hypothesis. I am supposed to take null hypothesis as a statement which is supposed to be rejected, because my major portion, my major population lies in alternate hypothesis only. So, when I am taking wrong decision, that means I am making type 2 error. If I am rejecting my null hypothesis, I am making type 1 error. If I am accepting my null hypothesis, I am making type 2 error, that is beta. Now, type 1 error, this is the probability of rejecting the null hypothesis when it is true. Type 1 error is when we are probability of rejecting the null hypothesis when it is true and an alternate hypothesis is wrong. The probability of making a type 1 error is denoted by alpha, and it is represented by the area under sampling distribution curve over the region of rejection. That means, this small part which we are rejecting leads to type 1 error. The probability of making a type 1 error refers to as level of significance. Level of significance, that means we want to take either 1% level of significance or we want to take 5% level of significance. Again, 1% means that there is only 1% probability that I am taking wrong decision, and 5% level of significance means there is 5% level of probability, 5% probability out of 100 that I am taking wrong decision. The probability of this error is decided by the decision maker that the hypothesis test is performed on the basis of his or her tolerance in terms of risk of rejection or acceptance, the true null hypothesis. The risk of making type 1 error usually depends on the cost and the goodwill loss of the organization, or we can say goodwill of the researcher. So, type 1 error is generally not supposed to be done, and type 1 error is associated with when we reject the null hypothesis when it is true and alternate hypothesis is false. The complement, that is 1 minus alpha of the probability of type 1 error measures the probability of not rejecting the true hypothesis and is referred to as confidence level. Confidence level means if the maximum value which I give is 1. So, what I am doing is I am just subtracting my alpha. Alpha is what? Alpha is my type 1 error value. When I reject, when I subtract my value, when I subtract my type 1 error value from 1, I get a confidence level. What is a type 2 error now? Type 2 error is, this is the probability of accepting the null hypothesis when it is false and the alternative hypothesis is true. The probability of making a type 2 error is denoted by beta, and the probability of making a type 2 error varies with actual value of the population parameter being tested when the null hypothesis H naught is false. So, what happens is the probability of committing type 2 error depends on 5 factors basically. What are those 5 factors? The factors are the actual value of the population parameter are being tested. That means, the actual values of the population parameters being tested, this is one thing onto which my type 2 error depends. Type 2 means my beta error depends the level of significance selected. If I am supposed to select 1%, but I am taking 5% level of significance. So, there are two levels of significance, that is 1% or 5% level of significance. The type of test, that is one-tailed or two-tailed test used to evaluate the null hypothesis. Here I am not knowing or not much aware about my directional or non-directional tests. The sample standard deviation called as a standard error and the size of sample. For example, I am not much aware whether I will be correct, whether I will be getting a correct answer from a large sample or from a small sample as well. From population of 1000, I am just taking 100 or I should take 200. That totally depends, the probability of type 2 error totally depends upon what the sample size should be, how much of the population can give me right answer or how much of the population size can give me wrong answer. So, the sample size is very important when we talk about hypothesis, when we talk about right answer, when we talk about how to just frame my question or how to lead on to the right answer as well. Thus, this is a summary of certain values of sample statistics, that is one of the tests, that is test Z. We will be talking about in the next slide as there are different kinds of tests. So, one of the test is Z test. This is a small summary of how the rejection area for two-tailed test or one-tailed test, how they lies and what are the values for the acceptance and the rejection areas when we are talking about the one-tailed test or two-tailed test. A small recap of what all we have done is a small thing, that is, first of all, we are supposed to talk about what are the acceptance area, what are the rejection areas. Generally, the acceptance area is a huge amount, is a big large area which lies in the bell shaped curve. When we are talking about acceptance area, we generally tends to mark major area, that means this area as the acceptance area, whereas this small area we talk about the rejecting area. Because why? Because we know that my acceptance area is accepted just because my answer, that statistics talks about this area, the answer lies in this area, therefore, this area is the area in which my answer lies. Thus, this is the area of acceptance, whereas my answer does not lies in this area of rejection, therefore, I am rejecting this area, and this, the line which separates the acceptance area and the rejection area is called as the critical value. I am supposed to do my research, I am supposed to do my study on the level of significance, that means what is the probability of making a wrong answer choice, that depends upon 5% or 1%. Along with this, we have also done what is the significance level, we have also done what are the different kinds of test, parametric and non-parametric test, which we will be going to study further in the next slides, and we have also done as to what are the points onto which the test of significance lies, what are the how to formulate a decision rule to accept the null hypothesis or to reject the null hypothesis, and we have also done what are the different kinds of errors in hypothesis testing. That is all from my side. Thank you so much.